Hey guys.
Morning, Monty.
Sorry, I'm really dark here today.
Bad mood. How are you, Pam?
I'm great. How are you?
Good. I had a kind of a meh week, but it's good. I had bug fighting basically, just in a project I'm working on. But,
Yeah, I know those weeks.
Yeah. So how's it going with you? What are you up to? Are you still working on your cool stuff? Did you get your simple example to work, or?
My simple, oh, not yet. No, I'm still working on it. But I got stable diffusion to work, so I was playing around with that quite a bit. So it was fun. Yeah, it is amazing how good it is. Yeah, because I played around with GPT-3 when it came around. It was okay. It wasn't great. It would sometimes spill out garbage, but this time, like whatever I asked of it, it gave me like great examples. Like it was really good.
Yeah, that's amazing. So I haven't had a chance, as I say. I've been bug fighting all week. So, but Rob, I did get your stuff going.
Yeah. Sorry, I got your message a little late. I was out walking with my daughter. She's back from Georgia.
Oh, she was still there during the war. Goodness.
Well, the war hasn't filtered into Georgia yet, except to the extent that there are a whole bunch of Russians who have left.
Oh, that Georgia. I thought there was some kind of war going on in the state of Georgia that I didn't know about.
War, but
I don't know. Maybe there's something going on there too.
So let me show Payam around this data set. Is that okay if we kind of spend a little bit of time looking at this?
Yeah.
Okay.
Oh, there's one other thing I noticed about that data recently that we ought to pay attention to. Need to figure out a way to kind of chop off, say, the top and bottom 1% of the distributions.
So to get rid of the outliers, do a bit of
Yeah, even though it's standardized, I was looking at it, and there are a bunch of cases where you've got, basically z-scores of 15 and 20.
Remind me what a z-score is. I'm sorry.
So, I mean, as a normal distribution means 0, variance 1. So that means, like 20 standard deviations away from.
Okay. Wow. That's...
which, yeah, I mean, for a standardized variable, that shouldn't happen. So what that's got to mean is it's been something like. I don't know, maybe a takeover offer or something like that.
Where it's just crazy. Okay, I understand. Yeah, so I basically, Rob provided to me, I'll just give you some idea of this data. Yeah, so it's 92,000 rows. That's pretty good. And each row has a stock symbol. So I'll just knock this out here. So let's load this up. So I packaged it all into a pickle file. So the entire data set, which is very large, actually loads in just a fraction here. And there's the data set. And this is the kind of data that we have. So what this is saying is Lee Ready is a standard metric for the number of buys and sells and all this other stuff. So there's all these different columns of stuff in the data. Then we have Apple, that's the stock symbol. We can change that, and there's a whole bunch of stock symbols. It's a very large data set, so I'll just show you. It's I
don't know, 200 megabytes or something.
Yeah, so it's 92,000 by 200 separate columns, and each column is a separate metric. I can show you the columns. I'll just do this in the loop actually. Anyway, so these are all the columns. We don't see all of the full name of them, but Rob, you can like it. I'm just giving you a sense of.
Yeah, it's kind of, like you were talked about last week, Pam, a lot of these are highly correlated.
Mm-hmm.
And they're just sort of different variants, so different ways of measuring trading volume,
Mm-hmm.
different ways of measuring average price and stuff.
Yeah, so yeah, there's a lot of columns. There's a lot. Yeah, so there is a huge number of metrics that we have access to associated with these different stock symbols.
So are they meant to be representing or having the same information, or some of them are very different and you have included them?
Basically, it's a laundry list of everything that people think they might want to pay attention to.
For liquidity.
Yeah.
I see. Okay.
And this underlying database, they're not saying, this matters or this doesn't matter. They're saying, all right, here it is. You do what you want with it.
Oh, I did something wrong there. Never mind. I was just trying to print them all, but it doesn't quite work. Yeah. So where I was going with this was a little bit different. So we did this in the past. So I'll show you a previous spreadsheet that we did do. We did this thing called the ARIMA test.
Mm-hmm.
And so what I did was I generated synthetic data. So I just created, well, I found a thing that does a Brownian walk.
Mm-hmm.
So and this is just to test it. And then we fitted an ARIMA model to the random walk. And we got these results back from the random walk. And then we did a covariance study. So I've done some of this in the past, and I could do this again with all of these values. I'm just not exactly sure. I also did some wavelet analysis, which is quite interesting. So you can see that there are these underlying trends, but as you increase the frequency, there is still interesting stuff in this random walk data. And then we can kind of smooth out the curve using wavelets, a bunch of different stuff. So that's all working. That's done. I did that a while ago. So we have all this ARIMA stuff and the wavelet stuff ready to go. And I also did some other stuff on denoising the data using wavelets. I don't know if you've used wavelets in the past.
Yeah, a little bit. Not for data science, but for other things.
Oh, okay. So that's one idea. And then the other one was in this SIGGRAPH video, which I'll have to dig up here. Just give me a moment. Yeah, this is the stable diffusion demo they gave at SIGGRAPH, and I'll take it offline. So what is this one? Just give me a couple of seconds, I guess. Sorry. Carry on. I'm just going to find this thing. I have to dig through all the conference notes. But essentially what they did, sorry, I'll just explain it by hand waving very quickly. So what they did is they realized that within the underlying data set, there was a, so the data set they had was webcams. So they put a webcam out in the wild and they just photographed every half an hour for 24 hours a day for 6 months, a scene using a webcam. And as you can imagine, the lights all over the place is very jittery. It just completely random fluctuations in weather and traffic and lighting and all these other different things. But they were able to fit a model to it, a very good model. And the way that they did it was they knew that there was certain features of the data that underlying features that they could target. So they knew that there was a 24-hour cycle. They knew there was a 12-month cycle. They knew that some things are linearly increasing and some things are exponentially increasing. And so what they did was they looked for all of those different distributions in the data and they matched them as best they could. and they were able to essentially anticipate them as being, I guess, principal components. And when they took account of all of these different known underlying time varying sequences, they were able to stabilize the whole thing. And you could basically say, show me October 21st on a sunny day, and it would render a perfect image of the time-lapse photography, which was amazing. I'll try and find the paper.
Okay, I'm just trying to understand. So if that date wasn't a sunny day, it could still generate a sunny
That's
day.
right.
Is that the
It's
model?
it's a fully trained generative model like stable
Gotcha.
diffusion.
Okay, cool.
Yeah. So if we could achieve something like that with economic data, that would be incredible. So yeah, let me once again, guys, carry on chatting. I'm just going to hunt for a couple of minutes. I do want to share this with you if I can find it. 1 sec.
So maybe Rob, while David is looking, so I'm trying to understand still, like, what would be the first sort of useful thing you could get out of this data? Like, let's say the first level of usefulness. What do you want? So let's say David develops a model, the input is this data set. What would you like to see as output?
So, I mean, I don't think anyone has really looked at this data yet, at least not in a comprehensive sense. So what I was focusing on is trying to come up with a predictive model that's useful about liquidity. So, I mean, the data is all organized by time. This is all on a daily level. So the question is, can I use information up to time t to predict what some measure of liquidity is going to be tomorrow or the next week? Now, in real life, I think a day is far too long. And what we'd like to do is, do it on a minute by minute basis or potentially second by second basis. I mean, there's so much stuff that goes on inside a second now. I mean, there's as much, what used to go on in an hour now goes on in a second, basically.
Yeah. So do we think, so in your data set, you had a bunch of companies, right? So let's say you're interested in predicting liquidity of Apple, as David was showing. Do we think that liquidity is a function of all those other companies somehow?
I do.
Okay.
And yeah, we don't really have a good process for thinking about how to incorporate that information yet. I do have another data series that's not part of this that I just found out about that tries to capture some of that more on an aggregate basis. So in other words, across the stocks. But it might make sense sort of to compute our own too, basically.
I mean, one simple thing maybe you can try is just keeping it super simple. Like, let's say we care about Apple only. So one idea is what you said, look at liquidity in Apple stocks up until some point and try to predict the later times. But what if instead of using the Apple data, we use all those other companies' data as input, either combined with Apple data or not, and just try to do your ARIMA or some other thing, right? To predict and see if the predictability improves or goes down, or is the same. I mean, that's one experiment you can try, right?
Yeah. So what's your sense though? I mean, we could certainly do that. So in this data set, I think there are like 367 stocks or something. And it's 1 year data, so 252 observations per, for the year. And then it's like 200 variables. So, I mean, we could throw in, include essentially lagged values of, some liquidity measure for the other stocks. But my intuition says it'd probably make more sense to try and put that into some sort of composite measure.
Mhm.
So my suggestion, and I want you to shoot it down because it's very naive. My naive guess was to try and understand like the difference between stocks will be much greater than the difference between the buy orders and the sell orders on a given day, right? So maybe.
Yeah, what do you mean?
Okay, let me share my screen and I'll kind of walk you through what I was thinking. Share my screen. This one. This one. It's not there. Why is that there?
Try turn on light here.
Sorry, one sec. It won't show. Oh, there it is. Okay. Yeah. So this is their model that I've been talking about. Yeah, so they, this is what I was talking about with the time series. So they kind of anticipated that there would be these periodicities in the data. And they also anticipated that there would be this kind of linear change or constancy in the data, and they can look for that. So they could say, given this section of the data, is it constant? Is it increasing? Is it certain periodic? So essentially they did a sensitivity analysis to these underlying patterns which were expected in the data. And then if there was a high correlation between the underlying pattern and the data, then they could say that the variance that we're seeing is explainable using these standard factors. And so we can essentially subtract out these standard factors and look at the differences from the norm. And so where I went was, can we do the same thing with this data? Can we look at the overall kind of growth in value of all the stocks across the time period and create kind of an exponential curve and then subtract that out of the data? Can we take the monthly or yearly or weekly or whatever it is cycles and once again do this correlation, like if the change in the data is fully explained by the fact of the underlying kind of pattern of the yearly seasonal changes, then we can subtract that out of the data. And then what we're left with is essentially is entropy, which is unpredicted variance in the data that we can't explain. And then
are there clear cycles in financial data? Like, I don't know, I guess there's every quarter, but is that something you're talking about, or is there more?
There's typically exponential growth in the market over time. Like if you plot the Dow Jones and you really simplify it over its entire life cycle, you'll find an exponential under there. Is that correct, Rob? I think you will.
Yeah, but you got to do it right.
Of course. And once again, this is very naive on my part, and I'm not an economist. So
yeah. So the only wrinkle is, well, a couple things happen. One is stocks paid dividends. And that's money coming out. So basically the stock price falls by the amount of the dividend that's paid out.
I see. So you could, once again, you could kind of create we don't know where these events occurred, right? So we either inverse compensate in the data to undo the effect of the distribution of the value that the stocks are generating for the shareholders or something.
Yeah, so let me just answer Pam's question a slightly different way. One of the maintained hypotheses in financial data is that it's essentially a random walk.
Mm-hmm.
And the intuition is, yeah, if you had some form of predictability, the market would figure it out. That information would then be reflected in the price and predictability would go away.
Mm-hmm. But isn't that exactly what you want to exploit? Those little windows of predictability to extract value from? If you can't do that, then what's the point of predicting liquidity?
Well, okay, so when I was talking about that, I was talking about the stock price or the stock returns.
I see.
What we're talking about here is a measure of how easy or difficult it is to trade the stock.
I see.
And for that, I do think we're going to see these sort of cyclical patterns like David had up on there. But that's okay. I mean, that's not a no arbitrage violation.
So the liquidity, we don't think is a random walk then.
That's my conjecture, yeah.
Okay, okay.
I just want to kind of finish on this paper because I think it's got some interesting insights. So this is their input data. Okay. So basic. Okay. Right, so we have this entanglement that he's talking about. I just want to give you a sense of what you get out of this because it's pretty extraordinary. Yeah, so
Boy, I did a lot of geoengineering there.
Yeah, is the input data not the same
okay,
as the
so
one
sorry,
they
I'm
run
just trying to get. Yeah, so now they can basically dial in the variables that they want and the model is fully controllable.
But the input data seem to be a different scene. Is that?
Say again, Pam, sorry.
The input data you were showing was a different scene, wasn't it?
Yeah, I mean, I can show you the input data for this in if you want, but yeah, so basically they just set up a webcam and let it run and you get all this gibberish, noisy data.
Oh, I see.
But because the data is IID in what you care about, other than these underlying kind of daily, nightly, day-night cycle things, you can train a model to essentially give you control of these parameters. So you can set the time of day, time of year, you know, and a few other bits and pieces. And then it will synthesize the variance of the unexplained variables. You know, it'll sample from the stuff that doesn't match the patterns that it knows about to produce images that are very consistent and coherent with what we care about. So
cool.
I'm just wondering if there's something like that that we can do with this data. I'm not sure.
So going back to that, so suppose we said, I don't know, 1 o'clock, September 10th.
That's right.
What would it do?
It would look at the data around September 10th to try and get us a localized sense of where it was in those various different cycles. It would feed those into the model as inputs. And then like Stable Diffusion or DALI, it would essentially synthesize a stable output that gives you an accurate prediction of what you would see at that time.
But hold on, I'm trying to understand. So can you specify a time? And I mean,
yes.
But can you specify a time like outside of the time of the input window and it will predict what it would look like?
Well, it's within the cycle of all you're doing is you're, sorry, let me share my screen again. So this is very typical in these models, these generative models. These are control variables. Right, so you train, whenever you train, you feed in, I know what time this photograph was taken, I know what time this photograph was taken, right? And so you feed in, it's like when you train an image of a cat, you feed in a picture of a cat, but you also feed in the word cat to say that this is a cat, right? So when you feed this image in, it's just an image, but you also feed in the time of day, time of year, trend input, and so on. So you feed in your control variables that you care about, and then you can then feed those control variables into the generator and it will generate a stable output. So
I'm just trying to imagine what this would be useful for.
This is incredibly useful because you can do things like this. Let me give you an example of how it's so incredibly useful. One sec, sorry. Okay, so here's one. So what's going on? Let me just, I don't know if you're hearing the audio of this. Do you hear what he's saying?
No.
So, right. So what he's saying there is that we can now sum across the whole year. So we can essentially stably sample every day of the year, and we can see what's changing in the data over the year after all these consistent factors have been removed. And what's changing across the year is the size and the colors of the leaves of the trees. Very useful, very interesting, right?
Yeah, so it's, I guess effectively this is like a sophisticated background subtraction method.
Yes, sure.
That
That's a
removes the
good
background. You don't
description.
care
Yeah.
about. Okay.
Yeah,
Okay,
yeah.
cool.
But you can tell it what you're interested in, right? So you can pick which of the variables that you want it to study, and you can hold the others essentially constant or invariant. And it will show you what the parameter that you care about is doing, right? So,
but I think here you have a huge sort of advantage that you have an anchor image that for the most part stays very, very stable, and there is some background stuff in it that's changing. Like for financial data, like I don't know if you have such a thing.
I would argue, but naively, that there is an underlying trend in the financial data.
Well, I'm sure there is. We just don't know it.
Well, that's what I was trying to get at with the wavelet analysis. Let me bring that up one sec.
Well, and the other part too is you built models for the principal components. It looked kind of interesting.
Yeah, I have to find that. Yeah, but what I'm trying to get at here is with the wavelet stuff, this is random noise, I'll be the first to admit. But these very low frequency kind of variances over time, this is synthetic data, so this doesn't have the logarithmic growth. But if I was, and I haven't done it, but I should, I will. If we can apply this to the stock market data as some form of aggregate, right? So if we could aggregate across all stocks and produce something equivalent to the Dow Jones or the S&P 500, where you have this kind of underlying trend, that's our stable background, right? That's kind of the thing that's not changing all the time. And then we can look for variance, if that's the background, we can then subtract that out and do what's interesting here. Why is Apple going up and everybody else going down, right? So there's some weird variance that we're seeing in the data, and we can see it because it's visually obvious that it's happening in some way. And then we can identify that as being interesting, and we can investigate why that is. And it might actually be insider trading or some collusion or something, we don't know.
I wonder if you just average across like all the companies, like average the liquidities and just plot it, do you see a pattern? I guess that would be interesting to see.
Yes, I haven't done that work. I'm very interested in doing that too. I just was wanted to chat with you
something
and Rob to see
sinusoidal, then maybe, or something that correlates with the S&P index or something. I think that would be like the background you're looking for.
Yeah. But Rob, is this an interesting approach, do you think? Or
yeah, I think it is. And I'm encouraged to kind of listen to you guys because you're coming at this from a different orientation. And yeah, so like I said, this data really hasn't been analyzed too much, particularly not sort of at this level. So I think anything we come up with is going to be kind of interesting and new.
Do you want me to send you the data? I'm very happy, Rob, if that's okay.
Yeah. I would love to play with it.
Okay, I'll just send you the pickle file. I've already, re-indexed it and everything. Otherwise, I just send you these gigantic. It's not that big. It's only 60 megs or something. I'll throw it up in my Google Drive and send it to you.
Okay. Okay. Sounds good.
And you have Conda set up or something equivalent to Conda set
Yeah.
up?
Yeah.
for
I can set that up. Yeah. That's fine.
Yeah. Okay. I mean, it has a bunch of standard packages, stats, and a few others. I can send you the links for them if that's useful. But yeah.
No, I can deal with that part. Yeah. Just the data is fine.
Cool. All right. I'll do that right now. Actually, let me do that. One sec.
Yeah, I guess, yeah, the only thing I would do is, and I'm not sure how to do this in the package I use. But if there's a convenient way of throwing out kind of the top, say 1% and bottom 1%.
So
I
this
would
is
do
in
that.
what quantity, top 1% or bottom percent?
Well, just of every single variable.
Okay.
They're all standardized to begin with. But I was looking at it, and yeah, there are a bunch of observations that, you're getting these huge, 20 standard deviation spikes. And the reason why I'm concerned about that is in kind of the clustering algorithms, the distance matters.
Mhm.
And if you've got a couple observations that are just way distant, it's kind of like, its impact on a regression line. They can make a big difference. And I'm not sure that really corresponds to much. I mean, I've tried to filter out kind of standard things I thought would generate those kind of results. Like, I don't know if you have a Berkshire Hathaway stock or an Amazon stock, or, Google. Yeah, things look a lot different than a Microsoft or an Apple because of the difference in price.
Mhm, mhm. The other question, I think you've talked about this before, but presumably like at least some of this liquidity change is probably explained by outside factors not in the data, right? I mean, that we accept, right? Like there could be something happen in the news. Elon Musk tweeted something and suddenly the liquidity of Tesla changed. It had nothing to do with anything that happened before it.
Yeah.
Okay, so we just accept it and there's nothing we can do about it at this point.
Well, I mean, I suppose, there's some things that you could kind of do. So, they're periodic macroeconomic announcements.
Mhm.
So something like that could happen.
Sorry, I'm back. Sorry, guys. I shared that with you, Pam.
I requested access. I didn't have access.
Oh, okay, that's fine. That's fine. I'm just trying to get past this. Share. So did that get you past it?
Yeah, I got it.
Cool. All right.
Yeah, so guys, don't go ahead and like post this stuff to the web.
Yeah, of course.
It's all very private, Rob. I'm not granting carte blanche to anyone. It's all
No. I view you guys as collaborators here in this investigation.
yeah, no, I asked your permission before I sent, and I would always do that. So yeah.
So this is so where is this data from? Is it, do you have like exclusive access to it, or is that like public data, or?
Well, our university pays for access to it.
Gotcha. Okay.
So it's from an outfit called Words, WRDS, which is a data product from Wharton Business School.
Mm-hmm. And if we do get anywhere, are you thinking of like publishing a paper or trying to make money out of it?
No, just publishing papers.
Okay.
If there's money to be made out of it, it would be from demonstrating that this could be done and has some practical value. So this sample, yeah, like I said, it's got, I think, 367 stocks. So what we would want to do at some point is to say, okay, we actually have about 4,000 stocks we can work with. And instead of just looking at a year's worth of data, we've probably got, I don't know, 15 or 20 years worth of data.
Mhm. But then you have to worry about things changing, right? I mean, Apple stock
Yep.
might be correlated with Microsoft now, but maybe 30 years ago it wasn't, right? Like you
Correct.
just don't know that.
Mhm.
Yeah, that's an interesting kind of area in and of itself, which is this decoherence and coherence, right? So they come into
Well,
alignment for a
You know,
while.
and then you've got these other events like, you know, what COVID did to the market in spring of 2020.
Right.
Financial crisis episode in 08, 09.
Mhm.
So I don't know how we compensate for those how would you compensate for those? I'm curious.
You know, I mean, partly, you know, it's an interesting question. So what happened?
By understanding, I see your point. Okay.
But I guess that's different from like if you're interested in predicting things in the next couple of hours, it's very different than understanding the trend over a couple of years, right? Those are different problems.
Yeah, I mean, one of the things I have seen in trends is that sort of these liquidity measures are improving gradually over years. So if we look, you know, if we went back 15 years or so, we would basically see a downward or, you know, a downward trend in transactions costs or an improvement in liquidity over time. So there is going to be some of that that's going to show up in the data.
Mhm.
Okay. Interesting. Yeah, so what do we want to do? Payam, if you're going to have a run at this, we could do that. I could fire up a Jupyter instance and share a, how do we want to share? Do we want to set up a GitHub so that we can share our notebooks or?
Yeah, I mean, we can do that. Yeah, I'm happy to do that, or you can do that and I'll join your, invite
Sure.
me to
Okay.
your repo.
I'll share what I've done. I've got a few notebooks I've already done on this related stuff with Rob's help over the last few months. So I'll put that up into the GitHub. Rob, obviously, I'll share it with you as well. Do you have Conda or something like Anaconda on your machine, or do you want me to set that up for you with you?
Me?
Yeah.
I think so.
Yeah. So if you can get Anaconda up and running, we can set up an environment where you can do all of this analysis locally in the notebook as well.
Okay.
So
yeah, I mean, generally, I wind up using now like
tools you're familiar with, I understand.
You know, that's another statistical package.
Wait, what do you use? Sorry, is it R?
What I generally use is a package called JMP, JMP,
Okay.
which is, you know, it does all kind of the standard machine learning stuff easily.
Is it open source free, or do you have to buy?
No, it's actually an expensive one, but I get access to it.
Yeah.
You can get it for like a month trial or something like that.
Mhm.
Obviously I've never been exposed to it, so I can't say anything about it.
Yeah, I've never heard of
No,
it
it's
before.
just it's good. It's easy. It's not great.
Mhm.
So it's what I use to teach my students. So
Oh, they get access to it. That's nice. Cool. Yeah. Yeah, I mean, I'm just using the classic Python standard libraries for economics and stuff, the stats libraries and stuff that work really well. So yeah, so I'll have to set that up. Let me do that today and I'll share that with everyone. Cool. All right. As I say, guys, sorry, I'm not that kind of on the ball this week because I've just been bug fighting all week. It's just.
Are there any conferences either of you are planning to go to this year?
I've got one. Is NeurIPS happened already?
No, it's in December, but it's in New Orleans. I'm not
Oh,
sure I
I'll
want to
attend.
travel.
Can you attend digitally?
You can, but they have made it so it's no longer kind of hybrid. They have an online version and then they have an offline version, and the offline version is way better. So I'm reluctant to pay for the online version now, because if they just stream the offline talks to everyone, I would be happy, but they don't want to stream those somehow.
So what
You
they did
wanna-
at SIGGRAPH is they had every paper that was presented, the authors had to do a video of the paper, which was posted when the conference opened, and you could watch all of the videos of all the presentations remotely without attending any
Yeah,
of them.
that might still be there, but my favorite part of these conferences are the workshop days, the last 2 days, and the workshops. They have separated it to the online version and the offline version, and they have nothing to do with each other. So they're not apparently recording the offline version, and those are the topics I was most interested in. So yeah, the other ones are all like, I don't know, diversity, whatever, black in, white in, AI, all this other crap that they want to keep springing up.
There's plenty of it, trust me. Oh no, I was in Europe, so that was crazy.
Welcome to my world, guys.
Yeah, so
This
I
is
would
being
love to go to
recorded
Europe.
because, again,
I just
can't say.
I'm having a bit of an income crunch at the moment because everything's gone very quiet. So I'm actually looking around for a bit of bit of income. So if I can spin up something, I'd like to go to Europe's or ICML. Where's ICML? Did we miss that for this
yeah,
year?
I think
well?
everything else is done for this year. All the ICML just had. I think actually all the talks became publicly open now. You can go check them
Oh
out.
really? Oh,
Yeah.
okay. I'll definitely have to track through those.
Yeah.
So those two are of great interest to me. I did see this one online, which I will share with you both. I don't know if that's of your interest, but it's certainly my interest. It's kind of a bit like the quantum gravity thing. It's this one. Check out this.
I mean, the reason I ask is I still have my $3,000 budget to go to a conference this year, and I haven't. I don't know where to
I
spend
go
it.
to Europe's. Yeah.
Yeah, but I don't know if I want to travel to the States.
Yeah, I
It's
mean,
always a
New
pain.
Orleans is kind of fun.
No, I like New York. I mean, I'm sure it would be fine. It's just getting through security in the States with all this chaos and all that stuff. Like, I don't know. It's never been fun. Every time I go to the States, I'm pissed off at the States. So I don't want to get myself into trouble. But okay, recently.
Yeah, I've always found it was easier going into Canada than coming back.
Yeah, I've stopped going to the States as well, Pam, just so you know. So like I don't go there at all anymore. So yeah. But that one looks interesting, so I'm probably going to attend that one. Looks kind of cool. I'm curious to see what they're saying. Have you heard anything further on the quantum gravity stuff? Like, was there any follow-up that you're aware of? I haven't received any.
No. I did have a question for Roger Penrose. I just on a whim, I emailed him. Like he has an Oxford email address, so I figured why not? I'll just ask him. And then I got an email saying, okay, Roger Penrose is 92 years old. He doesn't answer to email anymore. If you don't hear back within a year, then you're probably not going to hear back. That was really funny. So I'm going to wait for a year to see if he comes back.
Yeah, I know. That's what I was expecting. Yeah.
Yeah, at least you got a sense of humor.
Yeah.
Yeah. All right,
But
guys.
yeah.
Well, sorry, go ahead.
No, I was just going to say it's not a fast moving field, quantum gravity. So I think you can rest assured that they haven't cracked it yet.
No, I was out at UBC yesterday talking to a very interesting young lady, Donna Vacalis, and she did Rob's course, Robert Ness's course.
Okay.
And she really wants to get into causal inference, was asking me. Robert gave her my name so that she could talk to me, and I was chatting with her. And I suggested that she could work with Barenboim. He's in Columbia, I think. So I suggested that, and she was interested. But she's being interviewed by Yoshua Bengio and another guy to see if she wants to join Mila on Monday. So
Nice. Oh, check out the ICML stuff. I think there was a lot of causal inference talks and tutorials in this year's ICML. So I think that might be a good point to check. Yeah, I sort of gave up on that stuff. I don't know. I couldn't try to make it work for anything practical. So I'm waiting for them to figure it out a little bit more before I get back to it.
I haven't looked at it for a long time either. I've been looking at generative models, which use a very different regime. Yeah, so I've been focusing on the whole encoder decoder stuff moving through latent spaces. That's really been my.
There has been some like interesting directions of like combining causal models with neural networks. So I don't know if that have gone somewhere, but using DAGs, I think it's a dead end unless you're doing like something super simple. Like I don't think DAGs are going to get you anywhere that people haven't gone yet.
Yeah, I felt that the stuff that Bronstein's doing with geometric deep learning kind of eclipsed a lot of the causal inference stuff. Like it's like an order of magnitude more sophisticated than a DAG. So I'm going to actually, when I get a chance, go through Bronstein's. He's published his second round of lectures. Hopefully they're a little bit more intelligible than the first round. But,
yeah, that's on my list of things to watch. But yeah, there's a course that just finished. I think that's all on YouTube.
Yeah, I'm going to watch that one. Any book suggestions, Ryan? Any new books that you would highly recommend? Kind of books at the moment.
Yeah, I'm not in the middle of anything now. Just
No,
catching up with
neither
work.
am I.
Yeah, I'll let you know.
No, I'm actually going back through some of the previous books I've read, and it's very interesting to listen to them again in new light. So it's been. I really found David Hume to be really much more than I thought. Like basically, we've kind of given him the bumper sticker of the problem of induction. And that's it. And that's all we, whenever that's the only thing that people seem to draw from him. But I actually think he's the father of machine learning, because a lot of the stuff he talks about is at the very center of machine learning, this idea of priors and all you can know is from your priors. So if you can establish priors and you can make inferences, really sophisticated stuff. So.
Yeah, somehow like I don't know, you read all these modern stuff and you get a sense, you imagine there's some progress happening, but then you go read Hume and it says, of course, all that stuff was junk. Like it made a lot more sense when he said it.
Exactly.
Like, there doesn't seem to be any progress since Hume in any of this stuff. So
no. So yeah, that's really interesting. But I would highly recommend his first book, not his second. His second is good, but it's kind of.
But he backtracks in the second book a lot of the stuff he claims for in the first one, right? But you never know. I never know how to deal with that. Like Nietzsche as well. Like he has all these like different time periods that he contradicts himself. But I mean, which one do you pay attention to? Like I don't know.
Yeah. No, he softened. He certainly softened as he got older. Hume did, but his early work is really pretty crazy. Mm-hmm. All right, guys. Well, I think I'm done for the day. I will take a look at this stuff again, Rob. I did get it working and I did ping you, and we'll pick up on that. I'd like to get a little bit further down the track with it. And Payam, I'm very curious what you can do with it. So if you have a few minutes to play with it, I'll set up the GitHub and settle and get that going, and we can go from there.
Mm-hmm. Okay.
Sounds good.
All right. Thanks, guys.
All right. Take care. All right. And I'll be at the Doug's thing when that happens, of course.
Okay.
Rob. Yeah. Okay. Take care.
Bye.